A very good morning, my dear students. Now this time we are going to discuss assignment number 15 and the very first MCQ, which pair of compounds would make a NPK fertilizer? Do you know about NPK fertilizers? These fertilizers are rich in nitrogen, N, phosphorus, P, and K, potassium. Because all these are the nutrients for the plants and they augment plant growth. That's why they are shorthand called as NPK fertilizers. Now it is asked that which pair of compounds would make such fertilizers which are rich in nitrogen, phosphorus and K. A very routine preparation is by mixing ammonium sulfate and potassium phosphate. The next MCQ is farmers add calcium oxide, which is lime, and ammonium salts to their fields. The compounds are not added at the same time because they react with each other and they produce a gas, which is none other than ammonia. MCQ number 3. What are X and Y in the reaction shown? As ammonium chloride is reacted with a solution and some alkaline gas is released. So one hint is very obvious for Y, that when ammonium chloride is used, the gas which is produced must be ammonia. So you see, two options are giving ammonia as a product. Now we see which solution make it possible. It's not the acid which produce ammonia. It is a very strong alkali, that is sodium hydroxide. So the best option is C. Now we see MCQ number 4. Carbon dioxide is produced when X reacts with ethanol. Now you have to see, ethanol produces carbon dioxide only on combustion, and for this oxygen is required. And when we see from sodium carbonate, carbon dioxide is produced. So we see it's not some alkali, it must be the action of acid. So option C goes the right one. MCQ number 5. Which are the properties of an acid? Acid reacts with ammonium sulfate to form ammonia. No, it is wrong. It's not the property of acid. It is the property of alkali. And the second one is turns red litmus blue. Again, it can't be some acid. So none of the property is shown by any acid. Now we see the theory section. Acids are neutralized by alkalis. Write the ionic equation for the reaction between an acid and an alkali. Sodium sulfate is a soluble salt that can be prepared using a titration method. Name a sodium compound and the acid that can be used to make sodium sulfate by this method. Now you have to see a very common reaction between acid and alkali is reaction of hydrochloric acid with sodium hydroxide and sodium chloride salt, and water is produced. This reaction is called as neutralization because acids neutralize the properties of alkali and produced a water as a neutral product. Then tartaric acid can also be used tartaric acid can also be extracted from grape juice. The structure is given here. Just write the molecular formula for this compound by counting carbon number, hydrogen number, and oxygen number. When you write the correct molecular formula of tartaric acid, just try to find out the simplest whole number ratio to get the empirical formula. A solution of tartaric acid was titrated with 0.100 moles per decimeter cube. That is molarity of potassium hydroxide. That is the known molarity. Okay, now the equation is given, and one thing to notice here that 1 mole of tartaric acid requires 2 moles of potassium hydroxide here. Now we have to see how moles of tartaric acid will be calculated. First we see what are the moles available of potassium hydroxide. As you see, the moles can be calculated by molarity per volume. This is the only formula which relates the molarity, volume, and moles. Now, what are the number of moles? That's 0.1 known molarity, and 6 by 1000, because we have to convert it in the decimeter cube. So here we are getting the answer 0.0006. These are the moles of potassium hydroxide. Now we have to see how the moles of the tartaric acid will be produced. Okay, now we have to remember that 2 moles of potassium hydroxide are consumed by only 1 mole of tartaric acid. So we have to half the moles of potassium hydroxide. So here we have 0.0006 moles of potassium hydroxide. We half them and we are going to find out per 1000 ml. So here we get number of moles of tartaric acid as 0.0003. So these are the moles of tartaric acid. Now how we can work out for the concentration of tartaric acid? We will be multiplying the number of moles by 20. Again, it will be multiplied by 100. Here you will get the concentration, that is 0.015. Okay, this is the final concentration of tartaric acid, 0.015 moles per decimeter cube. The last task is on analysis. 8.0 gram of impure tartaric acid was found to contain 7.40, means when we crystallize impure tartaric acid sample, we found only 7.40 gram pure tartaric acid. So we have to determine the purity. How we work out for the purity? The grams of pure substance divided by grams of impure substance multiplied by 100, like 7.40 is the pure gram and 8.00 was the sample taken and multiplied by 100. Here you will get the purity of tartaric acid. Okay, I have winded up the discussion of all the worksheets by ending this video, and I am very hopeful that you will be completing your work as soon as possible, and you will be checking your understanding and you will be practicing the 5-year solution similarly. Wish you a very good luck. Take care and God bless you.